Great. So welcome everybody to the Chesapeake Fibershed meetup. And we are here today to talk about planning a dye garden. And I'm going to ask that everyone stay on mute while folks are talking, if you would. And if you just heard about sustainable cloth, so if you haven't signed up, please do so. And I'm now going to turn it over to Kirsten to do this program.
Thank you so much, and welcome to everyone. Thanks so much for joining on this lovely, beautiful day, which I'm sure some of you are keen to get out in the gardens almost. But we're really excited to bring together these two wonderful knowledgeable plant growers to start this conversation or continue our conversation about how we could sustain beautiful dye gardens and even foraging practices in our fiber shed. This is a moment when the world is really looking at the practices of dyeing, aniline dyeing, and looking at how we might make a shift to more regenerative practices using plant and mineral dyes. So it's really a very exciting moment to be considering some of the topics that I hope we will in our discussion. So just a little introduction. Pat Bedrowski is going to give us our presentation, and we are joined by Melanie Ruckel of Putnam Hill Garden, and she's going to join our discussion after the presentation or maybe during. Pat has a background in horticulture and historic gardening, plant dyeing, culinary arts, and painting, and I'm sure more. She's an author of a book called Gardening and Foraging Natural Plants. And she's going to touch on some exciting topics. She gave us a little hint. She's been doing some research into phytoremediation, growing a dye garden towards supporting pollinators, and how rain gardens might play a part in our dye practices. And joining us as well is Melanie Ruckel, who owns a really beautiful plant nursery, Putnam Hill Nursery, and many of you know her plants and know her from her presence at the Maryland Sheep and Wool Festival every year. Melanie has a long history of working with plants. She began as a child following her mother around in the family garden. And in 1989, she began her first horticulture job at a perennial nursery. And ever since then, she has devoted her attention, her every waking hour, to plants. And she founded her nursery, Putnam Hill Nursery, in 1996. And shortly after that, she was visiting the Sheep and Wool Festival here in Maryland with her sister, who I believe keeps sheep, maybe still, and is a fiber artist. And she was really interested to hear all of this discussion on dye plants, but saw that there was something missing. And so she began to integrate dye plants and make those available in her nursery as well. And I just want to share, Melanie shared a few words with me before, in Melanie's words, I just want to share this because I thought it was so lovely. It's her fascination with the usefulness and beauty of plants, their resilience and ability to give back just by being, that keeps her interest going. So I hope we can have a wonderful discussion with Melanie afterwards, and we'll start with Pat's presentation. And Pat has asked that if you have any questions along the way, please put them in the chat, and I'll try and delicately interrupt or bring those questions into the discussion as we go along. And then I would just say probably best to mute yourself for now, and then we'll open up the room for discussion afterwards. So thank you.
Okay, so can you see the presentation? Can you see the slides?
We can, yes.
Okay, good. All right, so let me figure out how to do this. Okay, here's I'll just start talking about this topic, and then, like you said, you can just interrupt if you have questions. So here's a little slide of a weld plant, and there's some goldenrod and sumac and other things that you can grow. It actually is pretty easy to grow dye plants in the Chesapeake watershed. So there's all these pictures covering up the slide. Okay, so anyway, here's some basic things to think about when you're growing dye plants. How do we know we're looking at a dye plant? Because in case you're foraging something or you have something in your garden already and want to try making dye from it. And then other questions, how do you make the dyes and why do they stick to textiles? What ones are easy to grow? What ones attract pollinators? Can we plant dye plants to remediate toxic soil? Like say you want to start a garden in your yard, and can you start with the dye plants to improve your soil? And then how can we store the dyes that we make for later on? So what does a dye plant look like? So it can be any part of the plant. It depends on where the color is concentrated. So it can be bark and the wood and the roots, the nut hulls, it can be fruits, it can be leaves, etc., flowers. And so you usually need quite a bit of it. So like you see that pokeweed, everybody says, oh, look at that color in the pokeweed. But then the dye itself is an anthocyanin, it's sort of unstable. And so it doesn't necessarily stay over years. You just have to keep re-dyeing with things. And of course, in that picture up there, you see this with the sailing ship in it. Those are dyes from long ago that we still have available, but historic dyeing gives you the dyes that have been successful for millennia. So those are all the historic dyes there from around the world. And so why does it work? That's my first question. Why do dyes work? Well, why do they stick to the fibers? And so there's actually these colorant molecules in the plant cell, and you can extract the molecules to make a dye with water or alcohol or fermentation or ammonia. And then we have to make it to the textile using other chemicals that are called mordants. So I have a cat that's being aggressive. Okay, so here's the colorant molecules. This is very fascinating because there's different kinds of colorants. The anthocyanins, that's the red ones. I got the wrong word. Flavonoids are yellow. The other carotenoids, we all know about them from carrots. And so these colorant molecules are actually in the vacuole of the cell. And the reason sometimes you don't see them in a class if you're looking at a cell under a microscope is that when you slice the cell, the vacuole empties all of its contents. So you have to really be careful to see these in real life. But you can see in that stem tip of the rose that those young leaves are full of those red molecules, and they are protecting the leaf from the ultraviolet light. Those are the emerging leaves, and they need protection until they become completely filled with the chlorophyll that's going to be working for the plant. So those are kind of like the fire squad. They're protecting the rest of the organelles in the cells, and that's why they're red. So there's all different kinds of colors. Everyone always asks, what's the difference between paint, food coloring, and textile dyes? And the thing is, the textile dyes must stick to the fiber. Not everything will stick to fiber and stay. And so some pigments for paint are taken out of the plants by precipitating them with chemicals. And that's really super cool. You can, I'll show you some more things about that. And then dyes for food, those are really pretty easy. They just have to be able to combine with the food and just pretty much water soluble. So the textile dyes have to respond with a mordant to stick to the fiber. And this is jewelweed. This was a big surprise for me. We just cooked up something in the yard and made color on wool. And then when I researched it, yes, people in the past have used that before. So here's weld. This is a plant that I got from Melanie, and it's growing there against that little wooden fence. And that's when it's going to bloom in the spring. The whole plant is full of yellow colorant. And Vermeer used this for his paint. So I decided to try to make paint from it as well. You see the girl with the pearl earring, that painting everyone knows. Well, her yellow cape was painted with weld yellow. And the way you do it is you make your dye bath, and then you extract the pigment, and which is in the sieve there, and then you can grind it up with whatever vehicle you need to make your paint. So he used oil. So definitely want to make weld yellow paint. So food coloring is a big topic right now, and because people don't want artificial pigments in food anymore, in India alone, they've identified 450 plants that can make colors for food. And though that's a huge area for research at the moment. And because a lot of health hazards were caused by synthetic colors. And I guess you know that already. Here's a little list of color pigments in the food that give health benefits, which I found really totally fascinating. If you have those colorant molecules that are give us color for our textiles, also if you're eating them, they are actually the component that is healthy in the food. So if you eat a rainbow, that's a good idea, but it's not just a advertising promotion. It's actually fact. So synthetic dyes, we all know about these, and this actually synthetic dyes began with this nice young man. He's 18. His name is William Henry Perkins. He's trying to synthesize quinine from cinchona bark, and he's working with a professor who says, "I'll take this home over Easter and try to come up with the chemical synthesis for this." And so he's at his home lab, and he's getting ready for dinner, and he mops up the lab really fast, and suddenly the lab desk turns purple. And he says at dinner, "Guess what, Dad? I discovered this purple dye." And the dad says, "This is amazing," because up to then they had logwood, which was really expensive, or this Tyrian purple, which is from mollusk shells. Purple was something you didn't have, basically, unless you were really wealthy. So now if this young man can synthesize it, this is revolutionary. So they establish a really lucrative business with the purple dye, and he does publish the recipe, but he doesn't publish exactly the recipe. And so for generations, nobody knew how to actually make this color. It started this fashion wave in the Victorian era called mauve measles from this color. And so later on, they took this sample that's pictured there, and they analyzed it to actually figure out how exactly he did make this color. So how can you identify a dye plant? Well, if you get some really good historic references, or if you look online, sometimes you can find great stuff, and you can experiment with plants on your own. And if you buy a plant and the botanical name says tinctoria, that usually means the word tinctoria means it was a dye or a stain long ago. And then this book by Dominique Cardon, this book is an incredible book. It's very expensive, but I finally was able to purchase a copy. This book has all kinds of dye plants, far reaching around the world, and everything very well explained with the recipes and the processes. It's a fantastic book. And there's plenty of dye books out there. So how do you grow your own dyes? Now, this is a really nice little dye plant garden in the Dutchess County Fairgrounds, where the Rhinebeck Fiber Festival is held. And I got to see this little garden. You can see there's marigolds and zinnias, and she's got woad and weld and everything. So here's how to grow. So there are certain rock star dye plants. And of course, from history, we have madder and woad and indigo and weld. And once you start studying old dyes, you recognize those, and you know they're always going to produce well for you. And then the ones to forage, like Osage orange wood is fantastic, goldenrod, onions, and walnuts. Those things you can always depend on, and you can make great dyes for kids with those. Now to grow, some of you already mentioned that you had marigolds. There's Dyrus coreopsis, like in the picture. Orange cosmos petals yield a brilliant orange pigment. It's stunning. And then there's weld, we talked about. Japanese indigo, that's a nice indigo you can grow at home very easily. And Biden's is yellow, woad is a blue, madder makes red from the roots, and Dyrus chamomile, happen to like that one too. So how do you get started? First of all, you need a lot of plants, because generally you have to harvest a lot of plant material for your dye making. And so the different ways you can propagate things, you can direct sow seeds, you can transplant seedlings that you get, you can divide roots, share with friends, and you can make cuttings like from trees and so forth. And here's a little bed of weld from the Dutchess County Fairgrounds, and that's planted in 2022 for harvest in the next year, because it's a biennial. So this brings up another topic. The plants have 3 calendars, and so annuals, we always think about putting seeds in the ground every year. Annuals produce seed in 1 year. The biennial is tricky because it grows 1 year and produces seeds the next. And then perennials are in the ground all the time. So those are the ones you can like easily share with dividing roots. And so when you want to start, you need to sow your seeds indoors or outdoors when it's warm enough. And what you want to do is check the germination temperature for each seed that you start so that you have it at its optimal growth. Otherwise, you'll be waiting and waiting for things to happen. And then when you finally plant them out, put enough space between so that you can get in there and harvest what you want. So here's a bunch of plants, the ones you get from Melanie at the Sheep and Wool Festival. And they're all going to grow like crazy. They're great plants. So here's some annual dye plants. Bidens is pictured there. One plant is enormous. Orange cosmos, marigolds. Hibiscus is fun. You can also buy just the tea bags. And then Hopi sunflower, Japanese indigo, red sorghum, which I was fascinated to read about. I put that in my book. Red sorghum leaves make red dye that's actually UV resistant. And it also will fluoresce. And then safflower, which is a very tricky dye to make. And then zinnias, which actually makes a nice yellow. So biennial dye plants, these are the ones that you want to start in the fall, or if you grow it now, just make sure you have some that overwinter for next year to make seeds and flowers in the spring. So that's like woad and weld, pictured there. Onions, Queen Anne's lace, by the way, is a biennial. So biennial plants, you can see which ones are which because they're going to be blooming really soon. And down here in Virginia, things are perking right up. This is in April last year. You can see how tall the weld is. It's already like 2 or 3 feet tall, and the dock will flower. And then madder, which is a perennial, it's only like 6 inches high. So you can tell that it's going to bloom much later in the year. Perennial dye plants persist many years, and like in dahlias, generally you dig them up to save the roots, and it depends on your climate zone. But there's a lot of great perennial dye plants. So when you establish your garden, you want to put those in place because they're going to be there every year and they're going to get bigger. And then you can put your annuals and biennials around them. I've got pokeberry in there. Don't worry, it's a foraging plant. Don't put that in your garden, really. So here's the plant hardiness zones in the Chesapeake Fibershed. And see what that purple dot down there in Virginia, that's where I'm living. And right now we've got all kinds of flowers blooming and stuff coming up. But I think up in Maryland, you're still, maybe your daffodils haven't bloomed yet, but ours are like, some of them are passing now. And our Fibershed actually goes all the way up to the lower area of the Finger Lakes in New York. That's why I put this huge map in. So what you'd want to do is figure out your climate zone in your backyard, and you can get in really close by zip code on the plant hardiness zone. So then you know your range of temperatures. And then if you want to be really clever and beat the season with row covers and things, you have to figure all that out. Otherwise, you look to see when your last frost date is and work from there. So here's some tips on transplanting. If you get a little pot with lots and lots of little seedlings, these are weld seedlings, you want to be able to give each of those plants maximum room for growth. These welds will get to be the size of a dinner plate. So generally you take the cell and open it up like a book, and you want to keep all those roots parallel so you don't disturb that tap root, that main root there. And then space each one about 10 inches apart, 12 inches, something like that, and you water them until they get established. They're nice and perky. So here are some tips on how to do this. So I've got this tool stuck in the ground. You want to make a hole. You pull that tool back and leave it in the hole to keep the dirt from crashing in. And then you take one little plant, hold it by the little seedling leaves, and get that root to dangle into the hole. And then when you pull your tool out, you can kind of pull it out so that the soil goes in around the root, and then you can kind of give a little tuck in. So did a lot of transplanting at Monticello, and this works. You can get pretty quick with this kind of thing. You can see my soil here is not ideal. It's heavy clay, and I put compost in it, but it's all lumps. It's like planting in marbles. So here's how dividing perennials. You can see that little root clump has been cut through the crown, which means where those plants meet the roots. You kind of cut that, but you still have dangles of roots in it. And and you can separate a mother plant into several, and then you want to space them out. And then you can do that in cold weather like now, if you're up there in Maryland, before they start really growing, so that they can recover in time to actually put out growth and can keep living. And then this is madder. And I wanted to show you this plant because you can see the red in the roots already. The madder is made from the plant roots. And on the right, you can see some mature roots about the size of a pencil. That's after like 3 years or so. But the ones on the left, that's a little seedling, and you can see how brilliant they are already. And so the cool thing about madder is that you need to harvest it after a couple of years and dig up with the roots. So how do you do that without killing your plants? Well, if you have 2 beds, you can harvest 1 bed and still have the other one going, and then put in all the little slips and pieces left over that you haven't used for dye. And you can also divide the plants as you go along. So generally you can put it in a tub or you can grow it outside. And I have read 2 different opinions about whether you can make new plants by putting the green shoots into the ground to make them root, but has never happened for me. So in Williamsburg, they actually grow the vertical part of it up a trellis, and so they can control the abundant growth in a more organized manner. And also needs a high pH, and it needs like a chalky soil, loose soil. So you can maybe put it in a tub. I included this thing about turkey red because it's so fun. Turkey was a color made from madder that was secret. And in 1785, this Scottish guy was in a Levant area, and he memorized the recipe and brought it back. He was like a spy for turkey red. And the process was 25 days long with 20 steps, and included saturation in rancid olive oil and sheep dung, a mordant. It's a tedious, long, stinky recipe. And it's actually fascinating because I've been reading about oil as a mordant, and it really does link to those particular colorant molecules in the root of the madder. Fascinating. And so, of course, I usually tell people, like, if you ever see anybody getting rich on dyes, at least in the past, somebody is being enslaved to do it. And so adults were kept secret in this Scottish town. You could not leave the town. You could not tell anybody what you did. They were all cut, their hands were all permanently tinged red. Of course, the river was polluted. This kind of thing today is trying to be overcome with better sustainable methods. And I'll kind of touch on that at the end. But I don't know if this is the source of being called red-handed or not, but definitely this was, I don't know, bad topic to talk about. Anyway, here's dye gardening into containers. Someone was asking about the raised bed idea. So here's somebody really cleverly using these muck buckets for growing their dye plants. And I have had the problem of having a deck with clay pots, and the pots get so hot that the roots actually die along the edges. So that you don't want to do. You want to have something big enough so that the roots will stay the right temperature. And then you can also like give that special condition for madder in a container. These containers allow you to maybe keep things away from animals that will predate. And you can also slip the buckets around into the sunlight and so forth. And so some plants, I've got a list here. People have recommended this: Japanese indigo, marigolds, Styrus coreopsis, yarrow, dahlias, cosmos, Styrus chamomile, and the wild indigo all grow well in these little tubs. What happened here? Something happened. Screen sharing, yes. Sorry, I got something linked, something odd here. Can't see my cursor. Shoot. Something funny happened just now. Do you know what to do with this? I can't get my, can you see the screen, or do you see my weird screen?
We see your screen and it looks just beautiful.
Just fine?
Yeah.
Yeah.
Oh. So my screen suddenly got covered with the Zoom call screen.
Oh yeah.
I don't know how to
If
get out of that. Let
you
me see, escape. Okay, escape. Okay.
there you go. Yeah.
Oh, but see, I can't advance any longer.
Hmm.
Oh, wait a minute. That worked, but I can't go back. Yes, I can go back. All right. Yeah, I wanted to show this. This is a large scale dye plant farming. This is really cool. This is a company in Tennessee that's growing indigo on an industrial level. It was a woman who founded this farm in 2012, and she wanted to make what they call traceable plant-based dyes. That means a plant-based dye that doesn't have something else in it. And she's having tobacco farmers turn their farms into indigo farms. So it's a really cool company to look at. They've got great videos on how to make all kinds of indigo vats. It's really cool. There. So we can grow indigo, at least I can in Virginia. I think up in Maryland and Pennsylvania, you'll have a little more difficulty, but there's a number of plants that have this indigo molecule, the indigo tin molecule in them. So here's some indigos. The true indigo, Farra tinctoria, is on the left. That's the one from India. That grows pretty short here instead of really tall, but we can grow it. And then this indigo Farra fruticosa, that's the one that made South Carolina famous with Eliza Pinckney's plantations growing millions of pounds of this that they exported to England. It's a fantastic story. The Persicaria tinctoria is a Japanese indigo up there on the right. That's totally easy to grow. Here, for me, it self-seeds everywhere. It just comes up great. And then there's woad plants there. And that picture I took this morning of the woad in my garden right now. And so it is an easy dye, and it grows here in Virginia year round. There's the plant I harvest on December 18th. I was worried it was going to freeze out. So I took the leaves off, put them in the freezer. I'm making dye from it now. And then here's plants today, the same plants. And so I've read that you can actually get 5 harvests from the woad plant, all those leaves off. But you do notice it's a biennial, and so you can see those flower spikes are kind of popping up now. It's going to bloom. So I'm really glad it's blooming. And as my little notes on the left say, it's outlawed out west because it does bloom so prolifically, makes so many seeds. But for me, that's great because I want ample seeds to be produced. One thing you want to do is save seeds from your dye plant so you can increase the number that you have in your garden each year. So now woad, in European history, woad was the dye of choice because it was Northern Europe. They can grow woad really easily. It financed whole towns in Germany and some in France. And then when Vasco da Gama went to India and found the true indigo, which was far stronger and maybe easy to use, when he brought back to Europe, he caused a big stir, and the government actually in Germany outlawed this thing they called the newly invented deceitful eating and corrosive dye. And then in France, there was an edict. You cannot use indigo, you had to use woad. But of course, that never happened. It eventually did use indigo. You can still find a woad museum. And then here's the Japanese knotweed. There's a number of recipes. I've got them here. They're online about how to make the dye work. And I saw some really beautiful dye yesterday. I think it was Cindy Connor's wool. What was beautifully done with her Japanese indigo, which was a dried leaf. So you can dry them. You can freeze them, whatever, until it's time to use it. You can see how the leaves are curling there. That's when the indigo tin is at maximum quantity in the leaves. And those leaves then you'd want to harvest and cut this plant back. It'll re-sprout from the sides and keep going. Has really great pink flowers. It really looks beautiful as a little bushy plant. And those pink flowers, of course, will give you seeds later on. So here, how to save your dye garden by, you can dry the petals, you can save the seeds, and you can make extracts. So here's when, of course, it depends on the plant. You want to make sure your plant's pretty mature. And it's my commentary is here about cutting the leaves, putting them in the fridge, or saving the dye, making the dye, saving in a jar. And madder, of course, you have to dig the roots every few years. And when you're going to gather flowers for dye, generally you wait till the pollen is on them and you see some insects pollinating them, and that's when they're at their max. So here's how I dry flowers. I just put them out on newspapers, and this is the bite-ins, and they do curl up quite a bit, but still the dye is pretty nice. So you can freeze this stuff. You can canned dyes once you have them made, as long as they can be boiled later. And so here's petals. I had not too many orange cosmos flowers, so I just pulled the petals off to allow those seeds to develop. And then you can see that beautiful orange color from the petals alone. It's fantastic. And so here's how to make a dye extract. Once you have the dye bath, it can be cold or hot, it doesn't matter. Then you put a couple tablespoons of alum in the dye bath. You stir it up, and then you add a washing soda to the dye bath, and it'll foam up like that, like up on the right. You can see it foaming out. And then that's making the pigment molecules precipitate out of the solution, and it'll end up at the bottom of the jar, and then you pour it through a coffee filter and get the dry molecules there. So that's a cool thing. And then here's saving seeds. You can see this is the orange cosmos in the green stage there. That's before they totally burst open, and then they're dried on the right side. They're really gorgeous little things. And so you just need to blow off the chaff from the seeds, and then I generally store seeds in the freezer. And so here's pollination. Now, this is a really great topic because Kirsten asked me a couple key questions before I started this presentation. So there is a lot of pollinators attracted to dye plants. So Doug Tallamy has a great commentary down here. It says, in the past, we've asked one thing of our gardens, that they just be pretty. Now they have to support life, sequester carbon, feed pollinators, and manage water. But the thing is, these plants, they've been doing it all along anyway. So, and then source I found, nurture, native. It says goldenrod is really, it attracts an amazing number of insect pollinators, and that is true. You can always find it loaded. So here's the Xerces Society is, they want to attract mostly butterflies. That's a really old group that is concerned about native species with native pollinators. And so you can see the Coreopsis fit that category, wild indigo, black-eyed Susan, sunflowers, goldenrods, etc. And then Doug Tallamy's got a number of nice pollinators listed here that include dye plants. And then I suppose you could go out there and try cow parsnip or butterfly bush. Maybe that would be a dye plant. This we haven't tried it out yet. So then I got interested in the natural dyes. I gave a workshop, and someone wanted to know about dye plants and how sustainable practices that they imitate or can initiate. So I found this really great website about sustainable colors in textiles using natural dyes, which is a huge topic right now. So there's actually a technology for creating new natural dyes using using agricultural waste like almond shells and beet residue. They're also using microbial pigments, and they have a way of making them stick to clothing without the clothing actually going into water. And this closed loop dyeing is really fascinating. It's where you have no waste at all. Once you made a dye and a mordant, you keep recycling those solutions and your natural pigments, and you don't put anything into the water, into the ground. And so when I was dyeing, we dyed when we had mordants left over, we threw them in the ground. The thing is, mordant solutions should be completely exhausted before you put that water in your ground. And then the mordants we use, alum and iron, generally, those are things that are not toxic to plants, and you can put on plants, like on your put alum on hydrangeas and turn them the different color to change the pH. So generally, they're not toxic when you're finished. But someone was asking me about making a rain garden of dye plants that can then suck up all of these solutions that you're throwing outside, which is a fantastic idea. If you want to know if you have sustainable dyes in your clothing, there's two certifications here: the Global Organic Textile Standard, it should be on the tags, and then there's a gold standard for harmful substance testing. So this is a huge field that I just sort of barely started at the tip of the iceberg here, but you can tell with these journals that I've listed on the right, everyone is concerned about the textile industry and causing waste and pollution throughout the world. So it's not a unique idea at all. It's being researched. And so, oh yeah, there is Fashion for Good, and they have a platform for encouraging companies that are innovative. And so Living Ink is actually producing ink for printing from algae. And they said instead of using petroleum product, remember William Henry Perkins, he started this whole petroleum product synthetic dye industry. Anyway, they're trying to make a really safe black ink, and you can actually buy some and try it out at home if you want to from this company. And then I already mentioned Stony Creek Colors that are trying to make indigo into a regenerative crop. You know, indigo blue is one of the colors that everyone wants around the world. And it was, even in the past, you'd spend 20 cents more in the 1700s for your cloth. It was dye blue. Everybody loved blue. So then Kirsten also asked me about remediating toxic soil using dye plants. And this became a really huge rabbit hole. So first of all, what do we mean by toxic soil? And that's the soil with high density atomic weight, atomic numbers metals, and the heavy metals: cadmium, mercury, lead, arsenic, zinc, copper, nickel, and chromium. And you can see this toxic waste side on the right. What they did is this has been going on a long time, trying to remediate soil with plants. They went to toxic waste sites and looked for plants that were actually surviving, and they understand how they were surviving. How did it work? Why were these plants alive? And so where do the toxins come from? It's oil and gas, phosphate fertilizers, mining, burning fuels. It's all the standard stuff that we all fear that it's in our land. If you buy a house, you don't know what your land had on it possibly. And so maybe you want to clean it up somehow. So people ask me about that all the time. These toxic metals don't leave. They are in the soil. They'll be there for years and years. Some of the soils are okay for plant growth, but in small amounts. The ones that are no function for plant growth are like lead, cadmium, arsenic, and mercury. So this is pretty cool, right? So how does it work? How does the phytoremediation work? Well, plants take the metals and they don't care. They just remove them or change them. And so it's called low technology and high impact. So far they've identified 450 plants. They're called hyperaccumulators because they take up this stuff willy-nilly and still live. And there's 45 plant families that are willing to do this. So they're saying, if you want to do it, use a non-edible crop and use like a tree, a big plant that maybe you're not going to eat, because if you don't want to possibly consume some of this stuff. You also want to find a plant that grows fast and big, like sunflowers and cannabis, which is like hemp. And somebody was talking to me about phytoremediating with hemp the other day. But are any of these dye plants? So keep going. This is the different kinds of phytoremediation. First of all, you have extraction, in which the contaminants are removed by the roots, and sometimes they're changed within the plant. Totally cool. Then there's phytovolatilization, which is when the plants suck up the toxins and they change them and they release it in the air. There's phytofiltration, when you take the toxins out of the water. There's phytodegradation, when the enzymes degrade the material within the plant. There's phytostabilization, in which the toxins are just held in the vacuole. That's the time, you don't want to eat those. And then they've engineered plants to grow faster. And they've also promoted rhizobacteria and fungi to help the plant suck up the toxins. So there are ornamental plants that have been studied for phytoremediation. So there's our favorite up there, the calendula and the marigold. And then on the right, I've listed all the plant families that have been researched so far: the cabbages, legumes, spurge, daisy, mint, and the figworts. That means like snapdragons. And some of those plants will pull up more than 2 elements. So like calendula will have cadmium and copper, and then marigolds extract zinc, cadmium, and lead. And so this is a cool little study they did between the French marigold and the African marigold. One's short, one's tall. Which one works better? So they loved marigolds because the animals don't eat them. They're called the pioneer species. They grow really well in poor soil. They're really super easy to propagate, have a short life cycle, rapid growth, a nice, healthy, big root system that's going to suck up all those toxins. And it rapidly extracts the heavy metals during its initial growth. So it's really good for crude oil fields, brown fields, landfills. So it's a phytoextractor and accumulator of cadmium. It tolerates lead, and it's a hyperaccumulator of zinc. So African marigold is bigger. It's 89% more dry weight than French marigold. So it accumulates more heavy metals because it's larger. And then it turns out that they both both kinds will take up cadmium and nickel. The big one pulls up more cadmium, and the little one pulls up more nickel and chromium. So it was kind of like, who's going to do what? But I would just say plant both, and so get them all out. Now here's phytoremediation by photovolatilization. That means the one that goes into the air. And this is when you have the pollutants are sucked up. Mostly they use Brassica juncea, which is the wild mustard, or canola, or the oilseed mustard. That, you know, this plant grows really fast, and it grows like through the winter for us. It'll convert selenium and mercury, but those two toxins, when they release them into the air, they might come back in the rain. But still, they don't dispose of these plants, or harvest and dispose of the plants. That was a big thing that we were talking about what do you do when you have a plant that's got the toxins in it? Where do you put it next? And I have not found out what to do next. So basically, you find a plant that's going to just change it within. Phytofiltration is when you have plant roots removing the toxins from water, and the roots convert the rhizosphere pH. Isn't that terrific? And then they they minimize how the heavy metals will move into the water. So it's just fantastic stuff. So how do they make a plant into a phytoremediator for water? So they grow the plants like cattails or whatever in a water system, in hydroponic system, and then they actually start gradually adding the polluted water to it so that the plant acclimates to sucking up polluted water. And then they take those plants and they release them into the contaminated site, and then they pull them all out after they've accumulated the stuff. And I don't know what they do with the plants after that. So in wetlands, you know, they use duckweed, water hyacinth, all these plants that people really never want in their little ponds, but these are the ones that are taking out all the pollutions. And then they also grow really fast, and so it's what you want. And then in terrestrial situations that are wet, sunflower, mustard, those two are the workhorses of phytoremediation. And then willow will also adapt to concentrations of, I think this is selenium nitrate or silver nitrate and chromium and magnesium and lead and selenium, plus petroleum hydrocarbons, I don't know what that is, organic solvents, and potassium ferrocyanide. So I guess if you have a willow tree in a yard that's been, reconditioned, let's say in the city or something, you could maybe clean up your yard. So I found this really interesting article about rain gardens in, I think, Portland, Oregon. Someone was concerned that rain gardens, of course, are sucking up pollution, and would they be toxic if children played in them, because maybe these pollutants are in the leaves. So rain gardens are planted purposely to like suck up water, yes, but they also catch 90% of all the metal, oil, grease, and hydrocarbons from the cars. And the polycyclic aromatic hydrocarbons is a huge word. That means the exhaust from cars. And they were found that a higher percentage of that was in the rain garden, but it was 1,000 times lower than the toxic level. And they said, well, why? How can it be in the garden, but not at a high level? And it turns out that within 2 to 8 days, these toxins are transformed in the rain garden. And 97% of the metals were captured in the soil, and 3% of the toxins were in the plants of the rain garden. So they weren't toxic to anyone if someone was in the rain garden playing, catching butterflies or whatever. And it worked really super fast. And so I was talking to somebody yesterday that we should just have all of these little gardens in the medians in our parking lots should be this rain garden kind of thing. It would be a cool idea. Absolutely working. And then the enhanced plants for phytoremediation, believe it or not, this pennycress, this is the stuff that everybody has, and they say, oh, I'm going to pull that out of my garden. This is actually accumulating zinc and cadmium from your soil. It's like awesome. And so they've actually bred some hyperaccumulators from the plants that already were accumulating. So they have a giant mutant sunflower that can extract 7.5 times more cadmium, 9 times more zinc, and 8 times more lead. So that poor little guy's sucking all that stuff up. And then I also used citric acid to help the roots accumulate more stuff. And then they also improve it by using the rhizobacteria and mycorrhizal fungi. And it's really fascinating because these things have been in gardening lexicon for forever. And now look at they're actually remediating the soil from toxins. So the rhizobacteria, under this intense magnification, they look like little tic tacs on the roots. And then you can see the little spore of the mycorrhizal fungi down there that's helping make the roots absorb more, because it's a big thing, kind of like a big tumor there. So the PG, that all this has to have acronyms. PGPRs, plant growth from promoting rhizobacteria. It promotes growth and fitness and protects against pathogens, increases the tolerance, because the roots sometimes have too many toxins around them. So now the roots have to regulate how many toxins are going into the plant. And then they also have these, they produce compounds like organic acids, and the siderophores is that kind of buffer zone for just filtering in as many toxins as the plant can stand before, it doesn't want to kill itself doing this. And so it's a really fascinating whole field of study. So dye plants for phytoremediation. Here we're finally getting to it. Carson, I hope you're happy that sunflowers removes, as we've been saying, chromium, copper, magnesium, zinc. Hairy goldenrod removes aluminum, and marigold accumulates the cadmium, lead, zinc, and nickel. And then if you look around, the mushrooms are great remediators. I have never even talked about dyes from mushrooms. Wheat, morning glory, and ragweed all remove lead. Bladder campion, that's a little weed. Silene vulgaris, you'll know this if you look it up. That removes zinc. Clover removes zinc. The brassica species, brassicas just remove everything. It's incredible. Alyssum has this thing called a binding ligand, which increases the xylem proportionately to how much nickel it's uptaking. And then the mustards remove, the zinc, copper, everything. So then I'm thinking, woe to the brassica. Why? Maybe that would be one of these remediators. So I thought the next step for me would be to take these little dye plants and grow them in our mortared solutions, or any metals that I can find, and just see how they respond. Oh, and then I thought I would end with the perfect outdoor kitchen for me. This is not my dream kitchen. This is actually a kitchen for dye making out in New Mexico. And you can see it has a stove, it has water, it has wood, big pots, just great. So I think that's all my slides. Here's my book. I wrote this book as a handout for the Maryland Sheep and Wool Festival. And now I'm thinking maybe I should update it with all this phytoremediation, if I can ever get that into a text format. And I have slides about foraging, but I think we are going to just stop there, right? And be able to have a chat. So how do I get to stop share? Here, escape. Here, stop sharing. Okay, is that right?
Yeah, wow. Well, that was, thank you. Tour de force. I just am speechless. Thank you for taking up all the little thoughts, seeds I planted about phytoremediation, and what a depth of information for us all to explore. That's exciting.
Yeah. It's mind-blowing.
Yeah, it is. We have some questions in the chat. I'm sorry I didn't interrupt, but we were deep in the water there, so to speak. Sorry for all the terrible puns, but so Mary Lou asks, any special soil conditions for indigo, and how much sun? So I guess,
full sun, and I don't think the pH has to be anything, but that's a great question, because I know it's grown in Ecuador with a pH is like 8.5 all the time. So maybe it is a high pH. That's a great question. I can look that up in Dominique's book.
While she's getting that, I'd like to show, Pat mentioned the yarn that I dyed with Japanese indigo. This is dyed with my dried leaves, and I was using directions to do that from John Marshall's book. But I also have dyed in the summer with fresh leaves using directions from Rita Buchanan.
Oh yeah, she's got great recipes, Rita Buchanan.
Yeah. A nice garden book too, of course, the Dyer's Garden.
Yeah. So any other questions?
Yeah, we have one from Porter. When canning dye, since it's not going to be eaten, is hot water bath canning okay?
Yeah, yeah. So I did pokeweed that way because people are always wanting pokeweed, and also because pokeweed has to be made with vinegar, and then you have a hot solution of vinegar and pokeweed, and a hot solution of vinegar in your wool, and then you move it at the same temperature from one pot to the other. And so I thought, well, the pokeweed is definitely one to can, because I don't have a lot of freezer space, and my shelves are pretty full of dried stuff too, and I don't think you can make pokeweed dye from dried berries. So that's why I put it in a canning pot. I also made the solutions and frozen them. But I think something fishy happened with pokeberry. So anyway, yeah, that's what I do. And goldenrod too, I suppose you can put in a dye bath in a canning jar. Most of the times I think my dye should be on a low temperature, because it just works better. So I'm looking for indigo in here.
We have another question, and please feel free to speak out loud your questions too. We're a small enough group that we can take turns going around. But from Lee, can we grow jewelweed in a garden? I've never seen it in a nursery.
Well, there you go, Melanie. Something new to grow.
Kirsten, I wanted to show you this hackle I have for you.
Oh yeah, great. Yeah, that's wonderful.
And
Exciting.
the spikes are about 1/2 inch apart. But here's a homemade one you can make with nails. It's the same spacing. And on my website, or my blog is directions for making that.
Great. Thank you for sharing. Yeah. Well, Melanie, what do you think about adding something like jewelweed to our gardens? I mean, it's pretty prolific in the wild. What do you think it's something, or
I wouldn't expect it to behave too much. It'll throw its seeds around. I mean, I think that the easiest way to do it would just to be, collect seed and throw them in your garden. I hadn't considered growing it as a potted plant, but don't put it past me. I'd consider it if people wanted it. But yeah, I think in any kind of wooded, near a stream area, we grow very well.
So the question was about regular indigo, right, Tinctoria?
Yes.
So they're saying just wild, it grows in flooded grassy fields and scattered trees, and on roadsides, bush margins, brushwood, secondary forest, anything with a certain annual temperature of 23 Celsius, which I can't translate. It occurs wild in most countries, Africa, Asia, Southeast Asia, but doesn't say anything about pH. So I think you'd have to do some more research on that kind of thing. But it sounds like,
yeah,
I don't think all those areas are naturally high pH, but I don't know for sure. I don't know.
And I've found that normally if they don't mention pH, it's probably just an average range. It's nothing extreme.
Okay.
Cool. I don't have golden jewelweed here, and I have been trying to grow it, and I can't get it to grow.
I don't have it either anywhere. I've looked and looked. Can't find it anywhere.
Yeah, and there's yellow flowered jewelweed up like in the Adirondacks, which is nice. So maybe this is not the zone for it. No, maybe it's just somewhere else.
When we hike around, it's typically near streams, right?
Right.
Yes.
Yeah.
Flooded areas.
It's called silverleaf.
Maybe it's a good one for a rain garden then.
Yeah. Right. So
I have a lot of it out
a lot.
so it grows. It grows.
one really
Yes.
cool thing I saw in this book was how to see if you have indigo in your leaves. And what they did is put the leaf of the plant in an ammonia vapor bath and analyze it to see if if the indigo is forming. So in case you're growing it and don't get a result, you know. But of course, I can't put my hand right on it.
And Pat, someone's interested in your dye book. I wonder, are you going to be at the Maryland Sheep and Wool Festival? And will it be for sale there? It's a nice
Yeah, I'm
place.
giving a workshop on Thursday, so I think I'm going to miss the main festival. But you know, you can email me. I can mail you a copy. Also, Clems and Clems, the guys who have the drum carders, they are selling it for me too. And actually, Melanie, you thought you'd sell some. Yeah, so I can give Melanie.
I
a
would
few
love to
copies.
have it here.
Yeah,
Yeah.
that'd be great.
And that gives everyone an excuse to go and visit Putnam Hill in person, which I did last year, and what a treat. So beautiful.
Maybe
Yeah.
Pat would come and sign books one day.
Yeah. Well, I've got this art show that I'm in on the 7th, and so I'm coming back to put up the art show. It's such a weekend. It's very busy for me this year. So yeah. Anyway, so here it's exposing woad leaves. I don't know if you can see this, but they've exposed woad leaves to ammonia vapor, and you can see the development of the indican in it. So that's super cool to me, because I think maybe essay how much colorant you have in the leaf with that method.
And
That's
Pat, you were saying you've harvested your woad leaves 5 times during 1 year. Is that right?
Well, that's what I read you can do. And so my plants are just really beautiful size now. And I did harvest already in December. And then now they're all beautifully bushy. I'm going to do it again. And they'll just keep pushing up leaves.
It would,
So
maybe there's a way we can share that, because I don't know how many people are growing woad, but I grow it as well. I bet a lot of people are, and I've heard sort of varying reports, like, you know, a little bit like the indigo, the dyer's knotweed or Japanese indigo, that it's there's more indican in the leaf in the first year and less in the second, as it, you know, goes towards its seeding, you know, fruiting year.
oh,
But it would be interesting to compare notes and see how that, yeah, see
yeah.
how it goes.
I know when I dried the Japanese indigo, the leaves are just really deep blue, just great. The woad was frozen already when I picked it. It just broke it off, and so I just kept it in the freezer, and now they can dye from it. And I didn't get to the part where you have to reduce it and everything yet. I was giving a workshop, and I thought I'll have the Japanese indigo and the woad and the indigo, and then you know, like 10 or 15 other colors, and we just didn't get to all of this stuff. So people weren't interested in the chemistry, really. They just wanted colors on cloth. So
What's your drying process? Do you just lay it out on newspaper in the sun, or do you use a food dehydrator? Or tell us more about that.
it's just newspaper on, you know, like in big flat boxes or screens. So I have enough screens, and like screens from windows, that kind of thing, and just out of the sun, out of the wind.
Yeah.
And you can, if you have enough boxes with like a little bit of depth to them, a couple inches, you can just, you know, alternate them and have the air like blowing through, and then I kind of sift them, you know, what do you call it, shuffle them around to let them dry.
Thanks.
I've got this cat biting me. He's been biting me during the whole lecture. He wants a treat. He's really nasty. Right.
Do people have other questions they'd like to share? I have maybe 10 on my list, but I don't want to
Okay,
be
good.
No, I think people from the room should please feel free to ask questions if you have other. I know Marion had asked the question of how to start a raised bed, and Melanie started giving us some nice tips on that. Do other people have questions about how to get a garden going or anything? We have this wonderful moment where we have people that have lots of experience, so feel free to jump in.
Well, I have a blog at homeplaceearth.wordpress.com, and in there you're going to see like 7 years of a lot of stuff, mostly about growing vegetables, but it's about gardening, feeding the soil with cover crops, things like that. And towards the end of, I mostly posted from 2011 to 2017. In 2017, I had a whole series of blog posts about cotton, growing cotton, and flax to linen. And then I backed off from it because I was working on my book, but occasionally I post again, but it's just out there. So anybody can access it.
So mindful of the time, it's 3 o'clock, and we probably want to give people some time for their afternoon. But if Mary, do you have a question? I see your hand up. Jump in, please. Oh, you're on. We can't hear you though.
Okay, can you hear me now?
Yes.
Yes.
Okay, so jewel weed for dye. Are you using the whole plant or
The whole thing. Yep, we just put it, the whole thing right in the pot. And I think we use
including
all
roots?
mordant. Mhm. Yeah.
Roots as well, just the whole thing?
Well, you don't want dirt, so we cut it off. Don't put dirt in your dye pot because then you have to get it out of your fiber.
Yeah.
So, yeah. And if you ever try a plant and it's kind of like loose parts, you can always put it in a nice mesh bag, make a big tea bag out of it to keep your plants, clean when you're trying to dye with them. So
Thank you.
yeah, I was fascinated with the jewel weed, but I put it in my book because it's been a dye plant in the past from other
And
people.
you, what color did
It
you
was
get?
peach, nice peach color. Yeah.
Wow, okay, thank you.
Yeah. So basically, when I give a workshop, it's kind of like to give people the tools to be able to know how to take a plant that they're looking at and put it through a mordant process or coloring and figure out how to make it into a color, how to make it work. So, and of course, indigo has its own crazy process of all its own, and it's totally on the other side of the planet. So you just have to know indigo and those kind of colors. How about the phytoremediation? Was it fascinating to anybody? Did you like it? Good.
I think that's a great thing of research to do that.
I think so too. And I think it would be interesting to share that with people growing food crops, and I mean, just how things could be really integrated, in a way that would be so beneficial to, to both dyers and, food people.
But I'm concerned if I have all the questions, maybe I think too much. I have all the questions of, are those heavy metals going to be in our food of the accumulators, or like if the sunflower seeds, or are they going to be in the dye that ends up in our cloth that's next to our skin?
Yeah, so
Those are
I
things
think
I worry about.
you have to see if it's accumulating only or if it's actually changing it. So if it's the volatilization or the other ones, then it's not going to be in that same form when you finally use it. But they did say don't eat the plants. If you're trying to clean up a site, don't eat the plants from that site. But then if you're making dyes from them, I imagine that's going to change it once again because you're cooking it and you're adding mordants and stuff. So I haven't been able to find anybody who's done that yet, taken something, a remediator, and made dye from it and then analyzed whether the dye is in the fabric. But I know it's a concern when you have cotton that's not grown organically. They're saying that those pesticides are in the cotton. So I don't know how they're analyzing that, and I haven't seen it yet. But there's tons of research at Science Direct, and then there's, I think, ResearchGate. Both have all these like scientific articles of, when everybody's just doing every little molecule, every little step, and they're trying to figure out everything before they say, go do this or that. They're just trying every bit, like even analyzing one marigold against the other. I mean, I was, it's fascinating by that.
There's a movement in East Palestine called Sunflowers for East Palestine to help remediate the chemical spill accident that happened there with the train wreck. And so they're telling everybody to, cut the seed heads before they produce seeds.
Well,
and
that's smart.
Going to be sending parts of the plants to, when they're half grown, to be analyzed. To double check and make sure, to see if there are any areas that are contaminated and which need to be remediated even further.
Yeah. And then they've got a whole problem with the season because it's still cold out there, right? So, but I guess everything will stay in the ground until they pull it out with something, with like
That's-
mustard and stuff. So
Yeah, that's right. But they're looking for donations for sunflower seeds. So if you have any.
we'll send them marigolds too. I think marigolds, you can underplant with marigolds.
Not exactly sure what chemicals they're looking for, but they
Oh.
seem to be stuck on sunflowers.
Yeah.
Do you live near East Palestine, Leah?
I don't.
So when I worked at Monticello, a lot of people would come through saying that they bought a house in town and they didn't know what was in their backyard and how would they start, with a garden. They wanted to grow vegetables. And of course they could have raised beds or a tub, but they wanted to know how to pull things out of the ground. And I think borage was being researched in Chile for pulling out something like lead or something. But there's been so much more research, I think, recently about all of the toxins that are present and how to remediate them. It's actually kind of a positive outlook, that things are observed and being, remediated even in the textile industry. So it's cool.
Yeah. And I liked how you said, these plants have been around doing all of these things all the time. And we just, it's now we, like Doug's Talamay's quote, now we expect them to, draw down the carbon and well, they were already doing that, but now we're measuring it and becoming sort of more aware of it for our, to help us out, really. I mean, and they've always been there helping us out.
Yeah. And then you think of all the new developments going up and they put in these bushes that are like useless. Basically, they could be putting in things that would remediate, or be pollinators or anything like that. So it's just good awareness to improve the future.
Well, thank you guys so much for this wonderful discussion. I think I feel inspired to go out and plant more. And I think that's the underlying message here, is that there's just so much more to explore and I don't know, green our planet more, to help in all of these different ways.
And I got to say that Melanie has a fantastic collection of plants. Like if you're looking for something really exotic and beautifully grown, just go over to Melanie. And you do mail order as well, right? Somehow you mail
Yes.
plants to people.
Yep.
Well,
We
maybe
do mail
we
order
could,
as well.
or maybe we could have a little Fibershed date and meet there at your garden and have a walk.
Yeah, totally.
That'd be
I
cool.
love that.
Yeah,
Trip to Putnam Hill. So
Yeah.
that would be
Great.
let's do it.
You tell
Can
us when the
exchange
best
info.
time to come would be.
That'd be great.
After sheep mule.
We'll all be breathing a sigh of relief.
June is always good.
Great. All right. So
Yeah.
we'll look forward to it.
A great program. Thank you.
Thank you all.
Thank you all for listening.
Thank you.
Thank you
And
for
thanks,
being
Pat.
here.
That was very interesting. Thank you.
Yes, thank you both.
Right. See you soon. Happy gardening.
Here.
Bye.
Bye.
Bye.